first of all, I'm going to solve that differential equation. So we start with our differential equation, dy over dx equals e to the y, 3x squared minus 6x. And to be able to solve this, we have to be able to separate it. So we have to have our x's and y's be separated by multiplication or division. So in this case it is. So I'm going to write this as dy over e to the x is equal to 3x squared minus 6x. Put the dx on this side, and I can integrate both sides. Now when I'm integrating this, I'm just going to rewrite this as e to the negative x, sorry, e to the negative y. That's e to the y, just make sure that's clear. E to the y, so I'm going to write this as e to the negative y dy, and I'm going to integrate this side. This is going to be 3x cubed over 3 minus 6x squared over 2 plus c here. And when I integrate this side, I get e to the negative y, and I have to make sure I apply that negative. So this simplifies to just x cubed minus 3x squared plus c. And I'm going to rewrite this as well and maybe move the negatives around. So first of all, I'm going to deal with that negative power, so I'm just going to write that in the denominator. I'm also going to apply this negative here, just divide everything by negative. So I end up with negative x cubed plus 3x squared, and this is minus c, or I can just leave it as plus c if I don't want to deal with that negative, but just as long as we're clear that if we do a plus c here, these are two different c's. But I'm just going to leave it as original c. I think it's easy enough to keep track of that negative, but that's up to you. So we need to solve for the c. So I'm going to go back to my initial condition. My initial condition here is 1, 0, so I'm going to plug that in. So I end up with 1 e to the 0, and that's going to be equal to, when x is 1, so I'm going to end up with negative 1 squared plus 3 times 1, so 1 cubed. Then we have our minus c here, and I'm going to plug in our x is equal to 1. So this becomes 1 is equal to negative 1 plus 3 minus c. So I'm going to say that c is equal to, I subtract 1 from both sides, I end up with c is equal to 1. So my differential equation so far looks like this. I still need to solve for y. So y is e over y, so 1 over e to the y is equal to negative x cubed plus 3x squared minus 1. Okay, and then I'm just using this equation and plugging the minus 1 into there. I need to solve for y now. So what I'm going to do is I'm just going to cross multiply this to get the y out of the denominator. So I end up with negative x cubed plus 3x squared minus 1 equals e to the y. I use logs to get rid of the e, so I end up with y is equal to log 1 over negative x cubed plus 3x squared minus 1. Okay, so there's my equation, my solution to that differential equation that goes to that point. I'm going to circle that. Okay, so we want to also find, so that's actually part B. So we want to also find the equation for the tangent line and then approximate a point at f of 1.2. So first of all, I don't really know what this graph looks like, but what we're going to do is we're looking at some point here. We need to find the linear approximation. So let's say that this point is at x equals 1. we want to approximate a point at 1.2, and what we're going to do is we're going to find the tangent line and use that green point on the tangent line to approximate 1.2. So I need a slope and I need a point. Well, I have my point at 1, 0. I just need to get slope, and I get the slope from my differential equation. So my original differential equation was dy by dx, so this is part A, is equal to e to the y 3x squared minus 6x. I'm going to plug in my x and y, and that will calculate the slope value. So I end up with e to the y, e to the 0, 3 times 1 squared minus 6 times 1, and that gives me a value of -3. So that represents my slope. And I'm going to use those coordinates and my slope to write the equation of my tangent line. So the equation of my tangent line is going to be y equals -3 x minus 1 plus 0. That's my tangent line. That would be that, this green line here. And we can approximate the y coordinate for 1.2 by substituting that into the equation of the tangent line, and we end up with, it looks like, going to be -0.6. Okay, so the original coordinate at 1, 0, if we use the tangent line approximation, we're going to be at -0.6. So there's my solution to part A. This solution for the y value, or the f of x, is here in part B.